Good morning, everyone. Hope you all are doing well. This is Poulomi Chaudhuri, and I'm working as an obsolescence engineer in Alstom Transport, Paris office. We are a dedicated team of 6 members in service platform, reporting to Stuart Broadbent, he being the obsolescence director in Alstom Transport. So we are primarily working to assist the different internal sites in Alstom in developing the different obsolescence management processes and providing solution to them. Currently, I've been working for a couple of tender activities supporting the requirements for obsolescence management and to give an estimate for the obsolescence treatment estimation. This being the topic that we will be covering today. So I would like to share my presentation with you for that. The agenda for the presentation will primarily encompass the importance of having this obsolescence reference costing estimation from Alstom's point of view as an integrator and service provider for turnkey rolling stock projects. So we will try to show how we have aligned ourselves with IC 6240 to 2019, how we have set up the obsolescence management process, and how we have allocated some specific cost across these different activities in support of this obsolescence management. And lastly, we have tried to showcase a couple of obsolescence treatment approach examples that Alstom has faced in the recent past. And as a conclusion, I would request for some suggestion and feedback from you in order to improve the approaches that we are currently having. Well, this slide shows the current picture of Alstom. There have been a recent development this year in February 2021, where Alstom and Bombardier, they have merged their businesses and become a single entity. So there has been an expansion of over 250 sites, both production as well as service sites all over the world in 70 countries. And the work capacity has increased. And as we know, with growth and expansion, not only increases the workload, but increases a lot of responsibility as well. It is of utmost importance to Alstom, like what we deliver to our customers, what we commit, not only for the production phase of the rolling stock, but as well as what we commit to give them a support in the as a part of the service opportunities or maintenance contract as well. When we talk about the service opportunities for this long, we have seen that we have been able to capture the maintenance activities or the maintenance costs associated with it. For example, the preventive cost, the corrective maintenance cost, the material cost, as well as the overall cost associated with it. But one major aspect which we have seen that is getting missed out in our considerations, it has been the obsolescence treatment cost. This is a huge cost contributing factor when it comes to the service opportunities. Our customers, they're also getting aware of the issues if this obsolescence treatment cost is missed out and what impact it can have in the long run. So they expresses nowadays they express their interest to include or to understand this obsolescence risk cost associated with the service opportunities, and there has been a demand from their end to include this risk as a part of the bidder scope itself. Now, speaking of the role of Alstom as an integrator and service provider, we are depending a lot on the external suppliers for products like the HVAC, brakes, then doors, for example. But however, after a prolonged discussion and getting into understanding of their product roadmap, we realize that even the mature suppliers are in a position to commit up to 10 to 15 years at max. But that is insufficient for Alstom, since we need to provide our support to the end customers for a period of near about 30 to 35 years. And here comes the picture of this obsolescence reference costing estimation, where a project level obsolescence management visibility becomes a mandatory for us if we want to meet our commitments to the end customer. Alstom, we ensure that the internal obsolescence process that is already existing, it is very much aligned with our IC 6240 to 2019, where it describes the PDCA, which is the plan, design, check and act for obsolescence activities. Under the plan category, we have phased out a couple of activities associated with it. For example, we do a detailed analysis of the requirements and specifications coming from the customers. Based on that, we try to highlight the high risk elements and we assign the mitigation strategies in order to provide a project level obsolescence management program. This comes under the planning section, whereas under the design, we try to cover the design considerations so that we can delay the obsolescence activities. We try to propagate the same information to the different design authorities or the suppliers who are responsible for providing the products. We try to contractually bind them to ensure that those become an essential deliverables to us. And lastly, we request for the product or the supplier OMP, which finally gets integrated as a part of the project level OMP. Next comes the check, which is in support of this project OMP. We try to monitor the items, we try to provide an yearly status and review meetings to check on the condition and the status of individual items affecting the project execution. And lastly, if there is an obsolescence issue, how we are going to act on it. Once we describe the existing process in Alstom in support of this obsolescence management, the next point which comes very important is to understand the customer requirements, the customer scope, what they are expecting from Alstom as a support for obsolescence management. For example, if we need to provide a project level OMP and there ends our responsibility, or we need to support them as a part of the maintenance support or spare part support as well, there the responsibility of Alstom increases, where we not only need to develop a project level OMP, but also we need to monitor the items and we need to provide an alert notification to the end customers, followed by the treatment of the minor and the major issues resulting due to obsolescence. Next comes, once the scope is determined, once the scope is decided and agreed between Alstom and the end customer, where we manage to build up a transparent understanding between the two entities, we try to do an assessment of the cost contributing functions at the very earlier tender stage or the bid stage. What we try to do, we try to map the activities cost contribution in the tender phase across the already existing activities which we do in support of obsolescence management during the project phase. I know, or rather, we understand that developing this cost estimation is of utmost importance in order to foresee the high risk that obsolescence can bring up to us. But what is important is, even if we know that the solution that we are providing or the solution that we are proposing in order to support the major or the minor treatment, eventually at the end of this 20 or 25 years, the solution itself might get obsolete. But what is important is we are in a mature position to predict or to foresee the risk associated with this obsolescence. When we speak about the maturity of project execution or a maturity with respect to a product roadmap, the first step is to identify the product breakdown. So this is a standard template that we have in Alstom. We generally take reference of a product breakdown structure, and across each item, we try to do a risk assessment taking assistance of ISA 6240 to 2019, where we assign an obsolescence risk, whether it's a low, medium, or high risk. And accordingly, we set up an obsolescence strategy, whether to have a reactive or a proactive strategy. Once the strategy has been decided, the next very important step is to identify the suppliers for those individual products. Why this step is very important is because once the suppliers or the design authority for those individual products have been assigned, we try to have an internal audit to understand the quality of the deliverables or quality of the obsolescence management process already existing in the organization. We try to refer again the PDCA, and we try to have a couple of questions in support of this obsolescence management, and we try to see where the supplier, the design authorities stand in terms of this obsolescence management maturity. Along with this input, we try to get feedback from the sourcing team and a couple of feedback that we receive from our recs from the earlier projects. The net outcome is the categorization or classification of the suppliers in terms of this mature proactive supplier, the intermediate mature proactive supplier, the new proactive supplier, and likewise for the reactive suppliers as well. What the nomenclature indicates over here is, for example, if we consider the mature proactive supplier, it indicates that they are the supplier for a proactive item, and when we term them as mature supplier, we mean that they are in a they are having a well understanding of the obsolescence management process, and they are already aligned with the requirements that Alstom has set up to support us for this obsolescence management. And we need not put a lot of effort to make them aware of the already existing obsolescence management process that we have. Once this maturity of the supplier is assigned, we try to allocate this relative hours with respect to the individual task that we have in support of this supplier obsolescence management program. For example, the first step is to proceed with the training activities. When we decide on a supplier, we try to get into a preliminary discussion with them to understand whether we are in same line or in the same pace and their understanding is the same as of Alstom. If not, we have to undergo a training or a preliminary discussion, couple of meetings to be at the same pace. The next step comes once the training period is over and we are clear on what the deliverables are, we get into a contractual agreement. And the last phase is final submission of the obsolescence management plan of the product or a supplier OMP. Now, the figures that we have indicated over here, these are a very relative hour allocation. For example, with respect to the Alstom design unit, if for the contractual obligation period takes near about 1 unit of time, we know that for a mature proactive supplier, the time or the effort that we need to put to get the documents arranged will be around 2 times the time dedicated for the Alstom design unit. So these are an indicative figures, not the real figures, but a relative hour allocation, which showcases how the estimation for the supplier management takes place in Alstom. Following this, the next step is the preparation of the project level obsolescence management plan or program. Now, for the preparation of this project level OMP, we know that we are depending uh, uh, quite considerably on a number of stakeholders. For example, for the assigning of this subsystem level risk assessment, or for the obsolescence management approach and the strategy that we are going to have for these individual products, we know we need to depend on the commitments that we are getting from the design authority or the suppliers, or what understanding we are having with the project manager, or if we have any recs from earlier projects. So all these points taken together, and with all this input coming, we know that it takes near about 60 to 90 hours to prepare and finalize a project level obsolescence management plan. And in total, to set up this project arrangement, for example, first to understand and note down the project requirements and specification, the analysis associated with it, then the supplier obsolescence management program, then the validation of the supplier OMP, then the formation of this project level OMP. All this time taken together is near about 450 to 650 hours on an average for a turnkey rolling stock project. The next step, which is a follow up of the already formed project level OMP, is the obsolescence monitoring setup arrangement. What we do over here is we try to develop a product breakdown structure and include the project details in TOMSIS, which is a system level monitoring and management tool used in Alstom. So for this, we are depending on two index factors. So one is responsible for assigning based on the ownership for the monitoring. For example, who is responsible for monitoring those particular product? If it is an external supplier, or the ADM parts, or the electronic parts, which is again the responsibility of Alstom internal unit, or be it an equipment level production unit, or if it is for a leading unit or the integrator site. And the next deciding parameter is the bill of material size. So we have another index across this bill of material size depending on the size of the product breakdown or the already existing BOM. Using these two parameters or using this two index, we try to make an assessment of the hours allotted for the total project inclusion in TOMSIS. And we have seen that on an average for a turnkey project, it comes to nearly about 250 to 350 hours. This hours is dedicated mainly for the setting up phase. But however, we know when we have a service contract or we have a support contract, there arises a recurring expense as well. We have seen that there are a number of alerts arising that we need to monitor, and on an average there are near about 40 to 60 alerts per year that we need to take action upon. And time taken to treat each alert is around 2 hours per alert. And what we do during this 2 hours, we try to update in the customer portal for notifying them, and we try to do an internal assessment. For example, we try to upload that information in our internal tools for further action, to check the availability of the stock, to check substitute item for it, or to see if we have any second source associated with it. But all these activities taken together, these are results of minor obsolescence treatment, which is not really a direct cost implication for the project. But what really impacts, or what is really having a cost implication from the project aspect, is the major obsolescence treatment cost. In order to understand this, or in order to understand the intensity of this cost associated with this major obsolescence treatment, we have tried to set up a couple of approaches. For example, once the obsolescence strategy for any individual product has been decided, we try to set this approach. If the strategy is having a reactive approach, then we know that no action needs to be taken. However, there are certain electronic items or some low voltage electrical items which we need to monitor, those having a proactive strategy. How, whereas the availability of those parts are really not of very significant issue, and we know that those items are easily available, so monitoring of those parts are sufficient. Hence this is also not having too much of cost implication from the project point of view. The approach too mainly indicates for the products, for example, the traction controller. Here we have given an image of the agate controller where we need to sustain the product for a tenure of about 20 to 25 years. Here we need to sustain it in terms of like some minor repairing or replacement of some specific items over here. We ensure that the product is sustained in terms of LTB, or we ensure that there is some second source of those high risk elements already available. So we need to monitor them and we need to keep the source active as well. And the fourth approach, which is again having a cost implication on the project, is the LRU replacement. For example, the display unit, we know that there is no partial repairing or partial replacement of it, but a complete LRU or assembly replacement demand coming from the customer eventually, maybe after a prolonged period of 15 or 20 years. So this is again having a major treatment approach. And needless to say, this will have an immense cost implication from the project point of view as well. Keeping in mind the four approaches that we described, or the three approaches that we described, we have tried to give some real-time examples over here. For example, the train control and monitoring system. Here we know that the breakdown comprises of the MPU, the DDU, input-output module, and network. uh, the product life being of 20 years, we know that there can be two approaches assigned to it. One is a complete replacement of TCMS, which means a total replacement of the TCMS comprising the MPU, DDU, IO module network, everything. And that will lead to a train level safety analysis and a couple of validation as well. The cost impact on the project is huge, major impact on it. Whereas the second type of contract, which is a support contract or the sustaining of the product contract, by doing this we can extend the product life by another 10 or 15 years, so finally giving a product life of 35 to 40 years, which is good enough a support period for the rolling stock lifespan as well. Here what we do, we try to monitor and check availability of certain items. We do a partial replacement of the DDU and some minor redesign. Then the communication cards replacement also take place. So a partial replacement, a partial repairing of it. This leads to a reduction of near about 65 to 90% of the replacement cost of the complete system. And it is a foolproof support contract that we are having. The next example that we would like to highlight is of the door control unit. Now, this figure is coming from a reliable external supplier who provided, or rather who suggested us for an LTP support which expired in 2018, followed by a repair support till 2021. And as the last resort, they gave us a suggestion for an alternative product post 2021 with a new generation control unit. And the major impact was there was a requirement of inclusion of a new door motor, and the cost for individual item that raised by 1.5 to 2 kilo euros, which was quite on the higher side. Whereas when we contacted a third party for the repairing contract or and an overhaul of the individual unit, we noticed that the cost was near about 15 to 20% of the upgraded new unit cost predicted by the supplier. The third example is of an IGBT obsolescence, where we see that there was a requirement of an FFF replacement of the IGBT, which was designed back in 1990, and it got obsolete in 2020. The new replaced IGBT, it is also having the same rating, more efficiency, but there is an issue with the form and fit replacement. And moreover, there was some issue, or rather the hing sink and the connectors, or the form fit, there was no assurance that that will be a similar type of the earlier version of the IGBT. Moreover, it demanded validation testing, plus there was a high risk for this get dry validation as well. So we see here that even if we are allotting a fixed cost of 50 to 100 kilo euro for the replaced IGBT, and even if it is having more efficiency than the earlier version, yet it was really not been able to fulfill our form and fit replacement requirements. A quick recapitulation of what we discussed so far. We discussed mainly on the estimation approach for both the process setup as well as a couple of approach for the obsolescence treatment that we have seen so far. Now, a proactive approach that we are having in order to make this assessment is of extreme importance to predict the futuristic risks that awaits us. Now, we will say that again, maybe the solution that we are providing at an initial stage is not a foolproof one, but at least we are having a budget, at least we are forecasting risk associated with it, which is also a major step in terms of the development to understand the obsolescence risk for such a prolonged support period of 30 to 35 years. And needless to say, Alstom is working hand in hand with the customers as well as the suppliers to yield the best outcome or the solution possible to make it more effective for us. That's all from me as of now. So I would like to ask for any queries or any feedback that you have. And in case you wish to contact me in the nearby future to discuss anything on this topic, I would be really happy to get an email or a call from you on this topic. So thank you very much, and have a pleasant day. Thank you. Thank you.